Every day, millions of single-use face masks end up in landfills or scattered across public spaces, posing hidden health risks and adding to plastic pollution. What if a single kiosk could validate, sterilize, and securely collect a used mask in under 30 seconds? Meet RenewMask. Next, an AI-driven dual-mode decontamination kiosk that combines targeted UVC exposure with a brief hydrothermal pulse and rewards users for correct disposal. Over the next 10 minutes, I'll explain the problem, how our system works at a practical level, what we expect to achieve, and the path toward pilots and deployment. Today's roadmap includes the context and motivation, the problem statement, our solution overview, results and impact, and finally, next steps and a call to action. Let's begin with why this matters. Mask use surged during the pandemic. Recent estimates put roughly 129 billion disposable masks discarded each month, which creates more than visible litter. Masks can retain viable viral material for days, and their polypropylene fibers break down into persistent microplastics that contaminate soil and waterways. Together, these trends overwhelm conventional waste and medical waste systems, increase costs and carbon emissions, and raise both immediate public health and long-term environmental risks, underscoring the urgent need for point-of-use, automated interception, and safe processing. Global mask use has exploded. Over 129 billion masks are discarded every month. Many enter ordinary waste streams or the environment. That creates three problems: residual contamination risk, growing microplastic pollution, and strained waste management systems that are expensive and carbon-intensive to operate. Improper disposal accelerates a public health threat. Masks can carry viable pathogens for days. Polypropylene fibers fragment into microplastics, harming wildlife and contaminating soil and waterways. Meanwhile, incineration and transport raise emissions and operating costs. Beyond the environment, improper disposal reduces public safety, degrades environmental health, and creates operational inefficiencies for institutions that must manually sort, transport, and process contaminated PPE. The cumulative effect is costly and avoidable. We identified three gaps. First, there's no widespread point-of-use sterilization. Masks go into general waste. Second, health and environmental risks persist because residual pathogens and plastics are uncontrolled. Third, the current pipelines are operationally inefficient. Labor, transport, and disposal costs are high. Our design objective: intercept, validate, sterilize, and secure masks rapidly, safely, and at scale. RenewMask. Next is a modular kiosk that combines QR code authentication, AI-powered vision to verify mask type and detect metal, a 10-second 254 nanometer UVC surface inactivation, a 20-second hydrothermal stage at greater than 80 degrees Celsius for deep sterilization, and secure collection with instant points credited to a companion app. The unit is field serviceable, supports height-adjustable solar panels, and is designed for high-traffic sites. Our differentiators are threefold: dual-mode sterilization, rapid UVC plus hydrothermal for layered efficacy, AI quality control at intake to prevent unsafe items, and behavioral design, instant incentives and transparent indicators to encourage proper disposal. Together, those elements deliver safety, scalability, and measurable engagement. Architecturally, the kiosk has sensor, control, actuation, and communications layers. Cameras, UVC dose probes, and thermal sensors feed a real-time controller, PLC plus microcontroller. The controller sequences doors, emitters, and valves, and publishes anonymized telemetry via MQTT over TLS to a cloud dashboard and the mobile app for analytics and maintenance. Hardware modules include the intake and camera array, UVC chamber, sealed hydrothermal vessel with PID control, locked collection bin, and optional PV panels. Software includes a CNN-based vision pipeline, the embedded real-time controller, and a user engagement API for point ledgers and leaderboards. The workflow is simple: capture, analyze, authorize, actuate, report, reward. The user experience is intentionally simple: scan, insert, UVC pulse, hydrothermal pulse, and secure deposit, all optimized to complete in roughly 28 seconds. Now I'll walk through each step. Step 1. The user taps the mobile app and scans a printed QR code. A token-based check validates the account and mask eligibility in under 2 seconds. For privacy, we log anonymized tokens only for reward accounting and auditability. Step 2. The user inserts the mask. High-resolution cameras capture orientation and visible material cues. Lightweight inference models run instantly. Non-conforming items are rejected and returned with an on-screen reason, for example, metal strip detected. Step 3. A calibrated 254 nanometer UVC burst, roughly 10 seconds, neutralizes surface pathogens. Inline dose sensors ensure uniform coverage. Safety interlocks keep users protected, and the system raises a pass-fail flag based on measured dose. Step 4. The mask enters a sealed hydrothermal chamber for approximately 20 seconds at temperatures above 80 degrees Celsius. PID control maintains a precise thermal profile, and sensors continuously feed back to the controller. Any anomaly triggers an automatic abort and quarantine. Step 5. The sterile mask is deposited into a locked internal bin. The companion app receives an immediate completion notification and credits the user's account with points. Each transaction logs anonymized metadata for traceability, and service alerts notify operators when bins need emptying. This closes the loop between action, verification, and reward. At present, these are predicted results based on component specs and bench modeling. Greater than 99.9% predicted pathogen reduction, an average cycle time of 28 plus or minus 1 second, and energy use near 0.22 kilowatt hours per cycle. Formal ISO and ASTM lab validation is scheduled next. From a systems perspective, we estimate approximately 120 mass per hour sustained throughput under continuous use, and a design target mean time between failures of about 5,000 cycles based on component reliability and redundancy. Our public survey found consistent themes. The largest barriers are convenience or laziness, low awareness, and absence of dedicated mass disposal points. Respondents said that facilities, education, and incentives would increase correct disposal. Respondents also indicated they'd trust an automated system if it is certified, sealed, and transparent, showing live dose and temperature indicators, plus routine audits and clear instructions. A tap-drop-go experience with visible certification increases acceptance. Selected comments reinforce those trends. Users want sealed handling, certified processes, and simple UX. Several suggested incentives or small rewards to nudge behavior. Others emphasize the importance of placing kiosks where masks are commonly discarded, near exits and transit hubs, to maximize impact. Predicted benefits include substantial public health protection by intercepting contaminated PPE, preventing more than 100 million masks per year from reaching landfill in pilot geographies, and operational savings estimated at up to 30% for large facilities. Market opportunity spans airports, hospitals, and government campuses, with recurring revenues from kiosk sales, maintenance contracts, and analytics subscriptions. Our roadmap, Q4-2025, integrate an advanced mass-to-fiber recycling module, Q1-2026, deploy 10 pilot kiosks across 3 major airports, Q3-2026, launch the cloud analytics and predictive maintenance dashboard, Q4-2026, commercial scale up to 100-plus sites. We've preempted common concerns. Metallic masks are detected and rejected. Privacy is preserved with anonymized tokens. Failed cycles are quarantined automatically. Construction uses recycled composites and corrosion-resistant materials. And physical security, anti-vandal enclosures, and audit logs protect operators and users. These measures are built into the design from day one. Thank you for exploring RenewMask next. If you're an institution, investor, or potential pilot partner, we invite you to contact us or visit our project page. Together, we can make public spaces safer, cleaner, and more sustainable, one mask at a time.